Hey, I'm Mr. Klein. Here are my hands, and here's today's lesson, which is going to be on something called the law of sines. I want to start by jumping back to something that we learned when we were in geometry, and that was about triangle congruence. There are some shortcuts that we can use to show that two triangles are congruent. I've written 6 choices right here for the triangle shortcuts. See if you can remember which 4 of them work. Just pause this video for a minute and then take a guess. Okay, I'm going to assume you've unpaused it, and I'm going to tell you that angle, 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 side, angle, side, and side are our triangle shortcuts. The 2 that don't work are angle, angle, and side, angle. More on that in a minute. Check this out. You know from way back, who knows how long ago, that we can write the area of a triangle as 1/2 its base multiplied by its height. I'm going to start today by giving you an alternate triangle area formula. Let's suppose that we call this angle A. And then we call this side right here side B, and this side right here side C. It turns out that we can actually use those 3 pieces of information to write a different area formula. And here's how we do it. See how this is not a right triangle? I'm going to drop a vertical here, and I'm going to call this H. So now we know that the area of our triangle is equal to 1/2 B, or in other words, this distance right here, multiplied by H. But here's the catch. I don't want that H there. I want this formula to be entirely in terms of side A, side B, side C, side B, and angle A. So what we're going to do is use the fact that if this is angle A, you can look at H, let me cover this up, as being the opposite, and you can look at C as being the hypotenuse. Therefore, opposite and hypotenuse tells us we're using sine. Hey, you notice today's lesson is called the law of sines. And the sine of angle A will be equal to its opposite divided by its hypotenuse. If we take both sides of this equation and we multiply by C, we get that the height is equal to C times the sine of A. Grab that, bring it down here, boo, 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 and plug it in for H. And we get this new formula that says the area is equal to 1/2 times B times C times the sine of the angle between them. And what I just said is really important. The idea here is you've got a side and you've got a side and you've got the angle between them, and that's what you use in order to find the area of the triangle. So there's our new formula. Let me show you how we could use that. Suppose we have a regular pentagon, and that this regular pentagon is inscribed inside a circle. And let's suppose we know that the radius of that circle is 10 centimeters. And let's suppose I ask you to find the area of the pentagon. Turns out we can use this formula to do it, and here's how. You start by noting the fact that if we add a second radius, we now have a triangle with 2 sides. If we could just find the angle in between them right here, we could use that to find the area of this triangle. So let's start there. Well, it turns out that finding the area of that's not too hard, because what we really have is 1, 2, 3, 4, 5 congruent angles. Boom, 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 boom. And those 5 congruent angles add up to 360 degrees. So 360 divided by 5 gives us 72 degrees. This will be 72. So if we want to find the area of the triangle right here, we would say, well, it's 1/2. Let's come back to our formula. Side times side, multiplied by the sine of the angle. And if you put your calculator into degrees and you multiply that out, we're going to get 47.55. centimeters squared. Well, since all the triangles are the same size, if you want to find the area of the pentagon, you just take 5 and you multiply it by 47.55. And you get 237.8 centimeters squared.